It's Claire here for Claire Maths. Today we're going to be looking at the 2022 National 5 exam paper 2 calculator for mathematics. Let's get started. Expand and simplify. I'll do this in my usual way by drawing a box. On one side goes one bracket, 3x take away 2, and the other side we've got 2x squared plus 5x take away 1. Also, there's lots of ways to do this. I'm just trying to get all the ones correct. So 3 2s are 6, so I've got 6x cubed. 3 5s is 15, so I've got 15x squared. 3 1s is 3, so minus 3x. 2 2s is 4, so minus 4x squared. 2 5s is 10, so minus 10x. 2 1s is 2, so plus 2, because minus times a minus is a plus. So that gives us 6x cubed. We've got 15x squared minus 4x squared, so 11x squared. We've got minus 3x minus 10x, so minus 13x. And last but not least, plus 2. Okay, next question. Company's annual profits is increasing to 215,000, increased by 3% a year. What's the per annual profit by the end of 2025? So our multiplier, 100 plus 3 divided by 100 is 103 divided by 100, which is 1.03. Start with 100% added 3%. So we take our money times by our multiplier to the power of 4, because it's 4 years between 2021 and 2025. And that's called appreciation. If you do that in a calculator, you get something like 241984.39, which to the nearest £1,000 is £242,000. And we're done. A concrete gate post is made in the shape of a cuboid with a sphere on top. And the sphere has a diameter of 0.4. The cuboid's a square base, important, length 0.48, with a total height of 2.4. Calculate the volume needed. So we've got the volume of a cuboid, which you just need to know is length times breadth times height. And we've only add on the volume of a sphere, which if you check the start of the exam paper is 4/3 pi r cubed. So I'm going to need the radius, well, the diameter is 0.4, so the radius is half that, which is 0.2. I'm going to need the height of my cuboid. 2.4 minus 0.4 is 2 meters. And last but not least, square base. So up here as well is 0.48. And that's has got all the information we need, so we can just substitute everything in. So for our cuboid, we've got 0.48 times 0.48 times its height of 2, and then for our sphere we've got 4/3 times pi times 0.2 cubed. So our cuboid, if we work out them separately, is 0.4608, and our sphere is 0.0335. If you add your two answers together, you get a total of 0.4943 meters cubed, or if you're rounding it a couple of decimal places, 0.49 meters cubed would be fine. Simultaneous equations for question 4. After writing an equation, 4 mangoes and 3 apples, 4 mangoes, 3 apples equals £4.25. Quite standard. Part B, 5 mangoes plus 2 apples equals £4.70. I have to find the cost, part C, of a mango and an apple. So I've got my two equations. We've got 4m plus 3a is £4.25. And we've got 5m plus 2a is £4.70. Times the top by 2 and the bottom by 3, just to get 6 in the second position. So that gives me 8m plus 6a equals 8.5, and it gives me 15m plus 6a equals 3 7s is 21, 3 4s is 12, 13, 14.10. I'll call that equation A and B, and we're going to do B minus A because the signs are the same, and it's easy to do 15 take away 8. 15 take away 8 is 7m. £14.10 minus £8.50. Well, you can just use a calculator for that. That gives you 5.6, which means dividing by 7m is 0.8. Let's call this one equation 1 at the top. We're going to substitute that into equation 1 to find our a. So sub into 1. So let's just remind ourselves of the equation. We've got 4m, so it's 4 times 0.8 plus 3a equals 4.25. That gives you 3.2 plus 3a is 4.25. So taking away 3.2, 3a is 1.05. And dividing, of course, by the 3, we get a equals 0.35. Not answered the question yet, though. We need to say a mango and an apple equals. So a mango equals £0.80. Or 80 pence, and an apple equals £0.35 or 35 pence. Question 5. A school netball team recorded the number of sit-ups each player completed in a minute, and here's the 7 results. Calculate the mean and standard deviation. So for standard deviation, I always use the second option, which is the square root of the sum of x minus x bar squared over n minus 1. So in this case, I need to draw my table out. Remember, we got this form at the start of the exam paper. So x minus x bar, x minus x bar, all squared. And we put our numbers in, which is 29, 27, 24, 31, 22, 19, and 30. And we need to total the numbers and get a total at the bottom. So the total of A numbers is 182, which means the mean, x bar in other words, is 182 divided by the number of people, which is 7. Which is 26. So we've calculated the mean, so we take away the mean for each of the numbers to get the middle column. So 29 minus 26 is 3. That gives us 1. That gives us minus 2. That gives us 5. That gives us minus 4, minus 7, and 4. Square each of the numbers, we get 9, 1, 4, 25, 16, 49, and 16 again. So our grand total is 120. So then we can work out our standard deviation really easy. It's the square root of the number we just found over 1 less than the number of things. Well, 7, so it's 6 players. 120 over 6. Do that all in the calculator in one go, or do the square root of 20, because 120 divided by 6 is 20, and you'll get 4.47. We've worked out the mean and the standard deviation. Okay, part B of this question, question 5. Some players in the school hockey team also recorded a number of sit-ups they completed in a minute, and their mean was 29, standard deviation is 3.2. As I've highlighted there, make 2 comments. So I need to compare the means and I need to compare the standard deviation. So let's just double check what mines were before. The first mean was 26, it's went up. So on average, the hockey team performed more sit-ups, as the mean of 29 is greater than 26. That's all we need. So on average, perform more because, and then there's my reason. Question 2, we're going to compare the standard deviation of the hockey team's setups and the netball team's setups. So the hockey team's number of sit-ups was more consistent as 3.2 is less than 4.47. Question 6. The diagram shows a triangle. It gives us two lengths, 25 and 32, and an angle in between, 58 degrees. Calculate the area. So we need the area of a triangle. Go to the start of the exam paper, and it tells us the area equals a half AB sine C. So C is our angle. So let's just cross that out and call that a C. And in between is our A and B. It doesn't matter what we call it, so let's just call that A, and let's just call that B. So there's my little A, and there's my little B there. So that's 0.5 times 32 times 25 times the sine of 58. Just get a calculator to work that out, and we get 339.22 centimetres squared, because it's area. Again, you can round if you want, but best not to round, just in case you make a mistake. Question 7, solve the equation 4x squared plus 2x minus 7 equals 0. Give your answer to two significant figures. Since it's telling me to round it, and it's a quadratic, I know that I'm going to have to use the quadratic formula, because it won't factorise if the answers need to round it. So we're going to check the start of our exam paper again, find the quadratic formula. I'll write it here, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and in this case a equals 4, b equals 2, and c is negative 7. So we just substitute everything in. So that gives us minus 2 plus or minus the square root of 2 squared minus 4 times minus 7 all over 2 times 4 minus 2 plus or minus the square root of, so we can do a bit in brackets first, 2 squared minus 4 times minus 7. That's 116. Just watch out for the minus times a minus, over 8. So remember, we split that into two sums, minus 2 plus root 116 over 8, or minus 2 minus root 116 over 8. Get a calculator, work out both sides. First answer gets 1.096, or about 1.1. And the second answer, I get minus 1.596, and a bunch of numbers, or if I want to round that, minus 1.6. The two significant figures for both of them. And that's me done. I've rounded it 4 marks. Okay, a train tunnel has a circular cross section with a horizontal floor, and here's the diagram below. Calculate the height of the tunnel. Clearly, to me, it clearly is a Pythagoras question. It's asking me for the whole height. Well, I know the radius from here to here, but I don't know this bit. So if I fill in that bit first, if I just draw a line down, make a right angle, then we've got 2 here and 2.9, so we can do I'll call this x. X squared is going to be 2.9 squared minus 2 squared. That gives me 4.41. So x is the square root of 4.41, which is exactly 2.1. So I now know that that's 2.1 using Pythagoras, and then we've got this extra bit here. That extra bit there will be 2.9 because it's a radius. So our total height just equals 2.9 plus 2.1, which is exactly 5 meters. Question 9 says solve this equation. 3 sine x plus 4 equals 6. So it's a trigonometric equation. So let me write that down. So the first thing I'll do is take 4 off of both sides to get 3 sine x equals 2, divide by 3 to get sine x equals, well, 2/3. So we can use our inverse sine button in the calculator of 2/3. And if you do that, you get an answer of about 41.8 degrees. But that's one answer. We need more than one answer because it's got up to 360. So at this point, we should draw a cast diagram. So we've got sine, and it's positive, so it's A and S, and this is 180 minus, remember. So the other answer for x is 180 minus 41.8. 180 minus 41.8 is 138.2 degrees. So there's our second answer and our first answer. Question 10. An attraction at a theme park has a carriage attached to an arm. The arm swings from A to B along the arc of a circle. Centre zero is shown in the diagram. Centre C, sorry. The length of the arm is 15 metres. The length of the major arc is 69.4. Calculate the reflex angle ACB. So in other words, this angle here. So let's just note some things in the diagram. If I draw round this bit here, that whole length is 69.4 metres. And we want this angle here, let's just call it theta. So remember, our formula for arc length is angle over 360 times pi times diameter equals arc length. Now I've already got the arc length, but I've tried to find the angle, so I'll just substitute everything in and work backwards. So our angle, we'll just call it theta over 360 times pi times, be careful, your diameter is not 15, that's the radius, it's 30. And our arc length was 69.4. Now the way I always work on these ones is just working backwards. To work out theta, I just start with my 69.4. If it says times, I'm dividing by it, times, so I'm dividing by this, but this has been divided, so I'm timesing it. So in other words, it's 69.4 times the 360, because that's on the bottom, but divided by everything else, pi times 30. And you can just work that out in your calculator, and we get an answer of 265.08 or 265.1 degrees. And we're done. Question 11 shows a cuboid, and it tells us some lengths, the 24, the 6 and the 8 as shown, and it's to calculate the length of EC, this space diagonal. This is 3D Pythagoras. Lots of ways to do this, but quite briefly, if I just draw something on here, if I go along here, that's at right angles, because it is a rectangle, even though it's drawn funny. If I calculate this length, that'll give us one Pythagoras once. But then if I start again with a different colour, since it's a 3D shape, this length and this length are also at right angles. So I can use Pythagoras again to get this length. So I'm basically doing double Pythagoras. So I can do, if I call that x and I call this y, I can say that x squared equals 24 squared plus 6 squared. And then I'm going to use that plus that to get y squared. So in other words, y squared equals the answer to this, 24 squared plus 6 squared, plus the extra 8 squared. So it's just all of them times added together squared. Okay, now you can do that in bits, 24 squared plus 6 squared, then square root it, then square it again and start again, or you can just do it all in one like I'm doing. So I'm doing it all in one, so I get my y squared straight away. That gives me 676. So y is the square root of 676, which is exactly 26 centimetres. Now, if you did it separately by doing 24 squared plus 6 squared, then square rooted it, and then squared it again, you may be off slightly by the rounding that happened, and that'll be okay, don't worry. But 26 is the exact answer. Okay, question 12. Simplify this algebraic fraction. So remember, when we're simplifying, we need to factorise the top or bottom or both. So let's factorise the top. Common factor for top. So I've got 2a is the common factor times b plus 2 times 3 is 6. So 3. There's my top. The bottom is a difference of two squares. So I just double bracket straight away. B and B, minus in one bracket, plus in the other, 3 and 3. I've chosen to put my plus in the second place to make it more obvious for you. You'll notice now you've got the same on the top and bottom. B plus 3 and B plus 3 cancel. So that leaves you with a final answer of 2a over b minus 3. Answer for factorising the top, then the bottom, and then your mark for simplifying. Okay, question 13. Simplify sin x plus 2 cos x over cos x. So this is one of these where you're having to use your trig identities, which are either sine over cos equals tan, or sine squared plus cos squared equals 1. Now, since I've already got a fraction in there with a sine and a cos on the bottom, I'm inclined to think it's tan, so I'm going to try that. So separating this into two fractions, we've got sin x over cos x plus 2 cos x over cos x. Well, sin x over cos x I've already discussed is tan x, but the second fraction we've got same and same, so they cancel. So we've got that plus 2. Put my degrees back in just to be clear. Oh, and that's us done. That's it. So as long as you knew sin x over cos x was tan x and you could separate the fractions, you would get your answer. Okay, question 14. The width of a river is represented by the diagram below, and AB represents a tree. From C, the angle of elevation is 28. From D, the angle of elevation to A is 12. These are both shown in the diagram. The distance from C to D is 15, as shown in the diagram. BCD is a straight line. Calculate BC, the width of the river. So it's asking us to calculate this part here. So you may not be aware of what we're trying to do here, but it's going to be the sine over cosine, or we've got angles and I've got triangles. So the first thing you should probably do is try and see if you can find any missing angles, just to make sure that you've got enough angles to play with in the question. So angles on a straight line add up to 180. So if I do 180 minus 28, that gives me 152. So I'm writing 152 degrees here. And we've got angles in a triangle add up to 180. So if I do 90 and 28, 90 and 28 is 118, leaving 62 up here. On the other side, we've got angles in another triangle. 152 and 12 is 164, leaving 16 up here. So we've got our two angles. We've got all the angles that we can possibly fill out. Now, you could do the sine rule on this. You could do SOHCAHTOA. There's lots of ways you could go to get what you need to get. I'm going to go for, I don't think SOHCAHTOA would actually work, even though I've got a right angle triangle. I'm inclined to think sine rule, and I'm inclined to think we'll just go ahead and do that and see what happens, okay? So let's just check to see what we need to find. We've got the length of this lever x. So you'll notice we've got this pair, but then we've got no other pairs in this triangle. It would work. However, since we've got triangle and triangle, this big one makes a triangle too. Let's call that one y. So we've already got angle, goes with that. But you'll notice in this triangle, we've got this angle goes here, and this angle goes with that one. So it is the sine rule. So the sine rule, remember, A over sine A equals B over sine B equals C over sine C. So we've got, in our triangle here, this one goes with this one. It's that angle. So it's y over sine 152 equals 15 over sine 16. Don't worry, this question is meant to be tough. It is the last question in the exam, so it's hard to see what it's asking. It's very, very much you need to think. So let's just rearrange that and solve it for y. So we've got y sine 16 equals 15 sine 152 degrees. So y is obviously 15 sine 152 all over sine 16. We can just use our calculators to work that out, and we would get 25.55. So we now know that's 25.55. So if we think of it as the big triangle, if I draw that out for you, where the tree is, we've now got 25.55 here. From the big triangle, we had 12 degrees down here. We had a right angle here, and we had 62 plus 16, that'll give me 78 degrees, because it's a big triangle. And remember, we're trying to work out the width of the river. So let's call that bottom bit, the whole thing, Z, because we're now on the big triangle. We've got opposite, adjacent, hypotenuse. So I've got adjacent and hypotenuse, so I've got cos of the angle equals our Z over 25.55. So Z equals 25.55 times the cos of 12 degrees, which is 24.99. But remember, that 24.99 is the length all the way over, because we've just used the big triangle. So I need to find x, but I already know it's 15 metres to here. So if I just take away 15, I've done it. So x equals 24.99 minus 15, which is 9.99 metres, all rounding it about 10 metres wide. And we're done. This has been Mr. Clem from Clem Maths. Today we've went through the 2022 National 5 Maths exam paper 2, the calculator paper. Take care, stay safe, and good luck with the rest of your exams.